Today we're going to look at factorising quadratics, and the learning goals for this lesson are that we're going to be able to factorise quadratic expressions and also simplify algebraic fractions that involve quadratics. So firstly, looking at monic quadratics. Monic means one, mono, one. So in a monic quadratic, we have a equal to 1 if our quadratic is in the form ax squared plus bx plus c. Now, any quadratic equation or quadratic expression rather can be put into this form in some way, just through rearranging or adding or subtracting collecting like terms rather to determine and to come to that general expression. Some coefficient multiplied by x squared plus another coefficient, another variable times x plus some constant term c. So in order to factorise a monic quadratic, we need to find two numbers that add to give b and multiply to give c. So we're finding two factors of c that add to give b. So we rewrite the expression then separating b into the sum of two numbers, and then we factorise by grouping, as we've seen in the last video. So if I've got x squared plus bx plus c, I need to find two numbers m and n such that if I add those numbers together I get b, and if I multiply them together I get c. So let's have a look at what that might look like. X squared plus m plus n times x. So I've found that number, that's b. This is b here, b. And then plus two numbers m and n that multiply to give c. This is c here. So I'm still in that format, x squared plus bx plus c. If I expand out the b term there to the x, well, I get mx plus nx and I get mn, then you can see I can now factorise by grouping. For the first two terms here, the common factor is x, so that common factor comes outside the brackets. And then for the second two terms here, the common factor is n. So we're left with x plus m being the common terms between the first and second terms now, and because x plus m is a common factor, we can take that out, x plus m, and have what is left over, which is the x and the n in the second set of brackets there, and that's how we can factorise it. Let's look at some examples now. So the first one here, factorising a, here it's x squared plus 8x plus 15. So I need two numbers that multiply to give 15 and add to give 8. So I could have a look at the factors of 15 here. I could go 1, 15, 2, doesn't go, 3, 5. 3 and 5 looks pretty good, because 3 plus 5 is 8. So because 3 plus 5 is 8, I can say, well, this is equal to x squared plus 3x plus 5x plus 15. And then we can just factorise by grouping. So in the first two, we've got a common factor of x, and I'm left with x plus 3. With the second two, I've got a common factor of 5 with x plus 3. Now x plus 3 is our common factor, and so we have x plus 3 out the front, and we're left with x plus 5. So that's now factorised. Looking at b, we've got x squared minus 5x plus 6. So we need to look at factors of 6. 2 and 3 are the only real factors of 6, or 1 and 6. But neither of those add to negative 5. If I'm going to get a negative 5, I'm going to have to use some negatives. So negative 2 times negative 3 is also 6, because negative times negative is positive, and negative 2 plus negative 3 is negative 5. So this works, x squared, so this equals x squared minus 2x minus 3x plus 6. For the first two factors, x is a common factor, left with x minus 2. For the second two, I've got minus 3 being the common factor, to be left with x minus 2. Now you notice I didn't take positive 3 as the common factor. The reason for that is because I need to be left with x minus 2 here and x minus 2. I need that second factor to be the same. So you might need to think creatively And if you don't get that same factor being inside the brackets, you might need to go back and think about how you're going to factorise it slightly differently. So x minus 2 is now the common factor, and I'm left with x minus 3 there. Looking at C, this one's slightly different. This doesn't immediately look like a monic quadratic. It looks like, hang on, there is a coefficient of 2 at the front. So there's the number 2 at the front here. It's not monic, but what we can do is we can take that common factor of 2 at the front to turn it into 2 times a monic quadratic. So we get x squared minus 5x minus 14 inside the brackets there. So I've got now I need the factors that multiply to give 14 and add to give negative 5. Factors of 14 that are probably going to be best, negative 2 and 7, 7 and negative 2. Now I can immediately see, oh, I've just done exactly the same thing there. So this should be positive 2 and this should be negative 7. But negative 7 and positive 2, if I add them together, I get negative 5. So that's going to be perfect for my monic quadratic here. So let's go with x squared plus 2 minus 7x minus 4, or 2x rather, minus 14. And I get here the common factor x in front, and I'm left with x plus 2. And then to get x plus 2 as the common factor for the second 2, or to be the leftover part for the second 2, I'm going to need to take 7. So I'll be left with x plus 2 there. And then that will factorise the common factor of x plus 2, and then I'm left with x minus 7, x plus 2, x minus 7 there. Last question here is we're being asked to factorise and then simplify. So we've got here x squared minus x minus 6 over x plus 2. So I need two numbers that multiply to give negative 6 and add to give negative x, negative 1. So negative 6, factors of negative 6, I've got negative 2 and 3 and negative 3 and 2. So to get negative x, I'm probably going to need negative 3 and 2 there, because negative 3 plus 2 adds to get negative 1. And I get x squared plus 2 minus 3x, sorry, 2x minus 3x minus 6 over x plus 2. And we will get a common factor of x out the front there, x plus 2. Minus 3 to get the factor of x plus 2 there over x plus 2, and then I'm left with x plus 2 being the common factor times x minus 3 over x plus 2. I can cancel the x plus 2's and I get x minus 3. I can only cancel the x plus 2's once it's been fully factorised. So I can only cancel the x plus 2 on the top and the bottom once we've got only factors. So there you can see they're multiplied together. Now I can start cancelling once there are no further added terms on the top line. Looking at monic quadratics now, non-monic quadratics, that's when we have a not equal to 1. These are slightly more complicated, but we still need to do the same thing, find two numbers that add to give b, but the numbers need to multiply to give a times c. So the best way to do this is to find all the factors of a times c and pick the ones that do add to b. So you need to rewrite the expression and then factorise by grouping, just as we do with monic quadratics. So if I've got an example here, 15x squared minus x minus 6, a here is 15, b is negative 1, and c is negative 6. So we've got 15, negative 1, negative 6. So a times c is negative 90, because 15 times negative 6 equals negative 90. So we need to find two numbers m and n, such that m plus n equals negative 1 and m times n equals negative 90. So we could list all of the factors of negative 90, But if we're cluey, we can figure out that, well, if I do negative 10 times 9, that'll get negative 90, and negative 10 plus 9 is going to be negative 1. So we can see here that we've taken those factors out, expand them out there to get negative 6, and then find a common factor for the first two terms. The first two terms common factor here is 5x. Take that outside the brackets for the first two terms. Then looking at the second two terms, the common factor is 3. We're left with the same 3x minus 2 now, shared between the first half and second half of our quadratic. So we can take that 3x minus 2 out the front, and we're left with the 5x here plus the 3. So let's look at some examples now. So 1a, we've got 6x squared plus 19x plus 10. Now off to the side here I can write AC is equal to 60 and B is equal to 19. Now we can list all of the factors of 60. We can go, well, we've got 2 times 30, that's probably not going to work. 3 times 10, probably not going to work. 4 times 15, there we go. So 4 times 15, 4 plus 15 is equal to 19. So that is going to be perfect for our purposes. 6x squared plus 15x plus 4x plus 10 now. So we've split our 19x up. You can see we've split our 19x up into 15x plus 14x. And so now we can factorize by grouping. Common factor for the first two is 3x. Take that outside the brackets. I'm left with 2x plus 5. And then for the second two terms, common factor is going to be 2. And I'm going to be left with 2x plus 5 there as well. So now I've got my 2x plus 5 for as a common factor here. I can take the 2x plus 5 outside the brackets, and I'm left with 3x plus 2. All done. Nice and tidy. Okay, looking at 1b now. We've got 9x squared plus 6x minus 8. Now AC here is going to be negative 72 and B is 6. So I need to find numbers that add to negative 72. That means one number is going to be negative, one's going to be positive. I could look at, I've got 2 and 36. I can do 3 and 18, I think. Where did I do that one? No, 3 and 24, 4 and 18, 6 and 12. But remember, these can be plus or minus. Now I want to get a positive 6. So if I take the bigger number minus the smaller number, 32, 24, that's going to be 19 here, looking at these ones. That's going to be 14, still too big. 12 minus 6 though. So if I have negative 6 times 12, I get my negative 72. All right, I get negative 72. And if I do 12 plus negative 6, which is the same as 12 take 6, then I get my 6 here. So they're my numbers. They're the ones I'm going to use. So let's have a look at doing this being 9x squared plus the 12x minus 6x minus 8. And common factor of 3x outside the brackets, 3x plus 4 inside the brackets. So we're probably going to need a common factor of minus 2 to get to the 3x plus 4 inside the brackets here. And then the common factor of 3x plus 4 between, we can see the 3x plus 4 is here and here, and then I've got left over, I've got 3x minus 2. So the 3x is from here, that goes there, and I've got the minus 2 there. All right, so that's our answer, 3x plus 4 times 3x minus 2. Now, this next one is going to be a little bit laborious. So we're asked to, for question 2, simplify this whole expression. Now, we need to do it step by step. We need to factorize everything down as much as possible and then see what is going to cancel. So I recommend doing each one step by step. Let's look at 4x squared minus 9 first. Now this is a difference of two squares. So the first square is 2x and the second square is 3 squared. So 2x squared makes the 2x all squared makes 4x squared, and 3 squared makes 9. So factorising a difference of two squares, we get 2x minus 3, 2x plus 3, if you remember. So that's that one factorised. We can look now at one underneath that. We've got 10x squared plus 13x minus 3. Now AC here is negative 30 and B is 13. We can look through and think about all of the different possible combinations we need, but for this one, all of factors of negative 30, but the ones that are going to work for this one are going to be 15 and negative 2, okay? Because 15 minus 2 is 13, 15 times negative 2 is negative 30. So we can make that equal 10x squared plus 15x minus 2x minus 3, and we get a common factor of 5x here. We get 2x plus 3 in the brackets. Now I've got minus 2x minus 3 here. That means I need to multiply both of those by negative 1 to get 2x plus 3. So this is going to be the same as negative 1 times 2x minus 3. It's the same as just subtracting away 2x minus 3 in brackets, but I'm just going to make it a lot clearer by saying we're subtracting 1 times that. So here, common factor of 2x plus 3, take it outside the brackets, 2x plus 3, 5x minus 1 is what is left over. All right, let's look at the next one. We've got 25x squared minus 10x plus 1. AC here is 25 and B is negative 10. So two numbers that multiply to give 25 and add to give negative 10 are negative 5 and negative 5. Negative 5 times negative 5, positive 25. Negative 5 plus negative 5, negative 10. So then this becomes 25x squared minus 5x minus 5x plus 1. Common factor of 5x. Take that outside for the first two terms. 5x minus 1 left over. Minus 1 times 5x minus 1. Now it needs to be minus 1 times 5x because we times it by the 5x. And minus 1 times negative 1, which becomes the positive 1. So this positive 1, we need to have a negative times a negative there to make that positive. That's why we've got the negative here. So this is going to be 5x minus 1 times 5x minus 1. There for that next one. And the last one, we've got 10x squared minus 17. Oh, that should be 17x there. There we go. That's a bit of an error. 17x plus 3. AC for this one is going to be positive 30 with B equaling negative 17. For this one, because it's a negative number, both those numbers are going to be negative, and it's going to be negative 15 and negative 2, because negative times negative, positive 30, negative 15 minus another 2, we get the negative 17. So then this is going to be 10x squared minus 15x minus 2x plus 3. We got a common factor of 5x, take that outside the brackets, and we get 2x minus 3. Yep, that all seems fine. Then we've got minus 2x plus 3. So if I want that to stay a plus 3, we're probably going to have that as plus 1. No. No, I need it to be negative 3 in the brackets, so it's going to be negative 2 because I want, negative 1 times 2x minus 3 because I want that to become a plus. This needs to be a plus 3, so we need negative 1 times the negative 3. So then we're left with common factor 2x minus 3, 5x minus 1. Phew! All right, now we've finished doing our factorising now. We've finished doing, we've finished doing our factorising, so now we can simplify. So what we can do, I'm not going to bother writing it out again because you probably don't have enough time to hear me listen to me all about that. So I'm just going to pretend I wrote the whole question out again, and then we write 2x minus 3, 2x plus 3, because that's our 4x squared minus 9 factorised. And then on the bottom, we've got our 5x minus 1 times 2x plus 3. And we've got, for the top over here, we've got 5x minus 1 times 5x minus 1. And then on the bottom over here, we've got 5x minus 1 times 2x minus 3. Let's look at what we can cancel. All right, so there's a 2x minus 3 here, 2x minus 3 here, 2x plus 3, 2x plus 3, 5x minus 1, 5x minus 1, and another one, and another one. Look at that, they all cancel. So that means we get this whole thing is equal to 1. What a letdown. Anyway, remember that the learning goals for this lesson were to be able to factorise quadratics, both monic and non-monic quadratics, and also be able to simplify algebraic fractions involving quadratics through factorisation.